Hi, this is Josh from Over the Shoulder Coding, where I help you prepare for software engineering interviews by guiding you through solving real problems. In this series, I will walk you through HackerRank's 30 Days of Code challenge day by day. This is the last video in the HackerRank 30 Days of Code series. If you like this series, please give the video a thumbs up and support me on Patreon so that I can make more videos for you. Today, we're discussing Bitwise operations. You can check out the tutorial tab for more learning materials, or you can check out a helpful Wikipedia page on Bitwise operations. What is a Bitwise AND? A Bitwise AND is when two numbers are compared, and looking at their binary representation, we see which ones both have a 1, or effectively are multiplying them to see which significant bits are 1. So here, 3 and 2, 3 is represented as 1, 1, and 2 is 1, 0. And they both have a 1 in the second spot, so that's 1, 0, which is also a 2. The bitwise AND operation is done by the ampersand sign. So you would do A and B to get the bitwise value of that pair. What we need to do today is, given a set of numbers 1 through n, we need to find the largest bitwise pair and make sure that it is less than an integer k. So in our input, we're going to get t for the number of test cases, as well as each line having two integers n and k. So the first one will be n, 5, and the second one will be k. So we need to find in the set from 1 through 5 the largest bitwise AND that is less than 2. So here is all possible bitwise ANDs. 1 and 2, 1 and 3, 1 and 4, 1 and 5, all the way to 4 and 5. And here are the bitwise values. And we need to find the largest one that is less than 2, which is going to be 1. Then we'll print that out and do the same for each line of the test cases. HackerRank has already parsed the input for us and broken it into n and k. And if we have a method that takes n and k and finds the largest max bitwise value, we can call it here and print out the return value. So let's define our method. Well, first we're going to have a placeholder for the max bitwise value. Then we're going to loop through the entire set of numbers from 1 to n. And we're going to do n plus 1 here because range in Python is exclusive of the last value. So we want to make sure that we compare n and not just n minus 1. And then we're going to loop through all the values less than I to do a comparison between I and j to get the bitwise value. Then we're going to check if the max bitwise is less than bitwise, the current bitwise we just got, and less than k. And if it is, we set max bitwise to be the current bitwise. Now, this is going to satisfy all that the question asks us to do. So we're going to go through all pairs of values between that set. So we're going to go 1, 2, 3, 4, and then go 1, 2, 1, 3, 1, 4, 1, 5. So I is going to be this value here that's increasing, and j is going to be the one that's underneath it trying to catch up, and we're going to do all the pairs. And the reason we only do j between 1 and I is because the bitwise AND is the same either way. So if A were 5 and B were 4, it'd still be the same value. And we get the maximum bitwise at the end because we've been replacing it if the current bitwise is greater than the maximum and less than k. And then we return it. But in this example, we loop through all the pairs only to return 1 at the end because that's the largest one less than k, which is 2. But we would have found that in that second case already, where 1 is the largest integer value that's less than 2. So we can return early. So if we know if maximum bitwise is equal to k minus 1, we can return max bitwise early and not have to search through the rest of all the possible pairs. We would save so much work. So let's test this out. Great, looks like we passed the 2 test cases. Now let's submit our code. It's taking a while because there's probably some test cases with really large n's. So by returning early, we're saving ourselves a lot of time and computation cost. And it looks like we passed all the test cases. Thanks for watching this video. If you've enjoyed this series, support me on Patreon by clicking the link in the description below. Don't forget to fill out the survey to help give me feedback and let me know what series I should tackle next. Make sure to subscribe and click the notification bell so you will know when I post the next video. Thanks, and I'll see you later.